I again welcome you. So our today's topic will be the derivation of the addition term. So we'll be talking about the addition term, the addition term of angular velocity. Let's try to derive it. Okay. So in order to derive the additional term, what I will do, let's suppose we have three frames of reference. Let me call this as frame of reference C. This is frame of reference beta. And let me suppose we have one more frame of reference, what we call as the ground frame of reference. And let's suppose with respect to C, in C we define a vector. In C we define a vector, and let's call the vector as vector Q. And let's suppose this vector Q is defined in frame of reference C. Okay. Therefore, we can take the derivative of this vector C. We can take the derivative of this vector with respect to the ground frame of reference. We can write this as derivative of vector Q with respect to ground frame of reference will be equal to derivative of this vector Q in C frame of reference. That is the derivative of this vector in C frame of reference plus angular velocity of C with respect to ground frame of reference. That is omega C with respect to ground frame of reference cross product with the vector Q. This is 1. I will call this as equation 1. In the same way, we can take the derivative of this vector Q with respect to frame of reference beta. We can write the derivative of the vector Q with respect to the frame of reference beta is equal to derivative of this vector Q with respect to frame of reference C plus angular velocity of C with respect to beta, that is omega C with respect to beta, and its cross product with the vector Q. We'll call this as equation 2. Okay. In the same way, we can also write the derivative of vector Q with respect to the derivative of vector Q can also be written as, we can also write this as the derivative of vector Q is equal to, if we take the two frames of reference, derivative of the vector Q with respect to the frame of reference, if we take beta and j, first we take the derivative with respect C and j, then we took the derivative between C and beta. Now let's take the derivative between beta and j. Derivative of the vector in frame of reference, derivative of Q in frame of reference j will be equal to derivative of the vector in frame of reference beta with the additional term in frame of reference beta plus angular velocity of beta with respect to ground, that is omega beta with respect to ground, and its cross product with vector Q, which is defined. So we call this as equation 3. Okay. So this is if vector Q is defined in C, and we take the derivative between C and J, and this formula is when we take the derivative between C and beta, and this formula is when we take the derivative between beta and J. Therefore, let's do one thing. Let's add equation second and third. So add equation second and third. Adding equation second and third, we get derivative of Q with respect to beta. We get the derivative of Q with respect to beta plus derivative of Q with respect to ground is equal to derivative of Q with respect to C plus derivative of Q with respect to beta plus addition of these two terms. They can simply be written as angular velocity of C with respect to beta cross product with angular velocity of beta with respect to ground addition term will be used, and its cross product with the vector q. Okay, so this is what we obtain, and we call this as equation 4. Okay, so what we do now, subtract uh, we will subtract equation 4 from equation 3. Subtracting equation 4 from equation 4 from equation 3. Okay, let's subtract these two equations. So as we subtract 4 from, first we can write, as far as derivative of q with respect to b and this derivative of p, they will cancel each other. Okay, so let's now subtract equation 4 from equation 3. So this will be derivative of q with respect to j, derivative of q with respect to j or ground. So as we are subtracting this equation from this equation, therefore this and this term will cancel. That is, this and this term will cancel. Okay, then we'll be having derivative of this will be derivative of let me first clean the diagrams. So let me first write them properly. Let me not call this as equation 4. Let's call this as, so derivation of c with respect to beta will cancel. So it will be derivative of q. So we'll be having derivative of q with respect to ground is equal to derivative of q with respect to c. Derivative of q with respect to c plus angular velocity of c with respect to beta plus angular velocity of beta with respect to ground and its cross product with vector q. Let's call this as an equation 4. Okay, so what we will do now, we'll subtract equation 4 from equation 1. Subtracting equation 4 from equation 1. Okay, let's subtract these two equations. This equation we have to subtract from this equation. Okay, so as we subtract the two equations, what we will get, as we subtract the two equations, we'll obtain, as we subtract this equation, we are subtracting from this, so this and this will cancel, this and this will cancel. So we are subtracting this, we are subtracting 4 from 1, so we'll be having angular velocity of c with respect to ground cross product with q minus angular velocity of c with respect to beta plus angular velocity of beta with respect to ground cross q is equal to 0. Okay, therefore the equation becomes we can write this as, this is angular velocity of c with respect to ground minus angular velocity of c with respect to beta minus angular velocity of beta with respect to ground. Cross product with q vector is equal to 0. Okay, q cannot be equal to 0 because q is a well-established vector, non-zero vector. Therefore, angular velocity of c, therefore what we will obtain, therefore this term is equal to 0. That is, this is equal to 0, which implies angular velocity of c with respect to ground is equal to angular velocity of c with respect to beta plus angular velocity of beta with respect to ground. This is the expression that we were trying to derive. Okay, this is called the addition theorem. Angular velocity of c with respect to ground is equal to angular velocity of c with respect to beta plus angular velocity of beta with respect to ground. these are the three important terms that we should be, three important properties rather, that we should be actually knowing before we go ahead in understanding the kinematics of three dimensions. So what I will do, let's take up few problems from the kinematics of the three-dimensional kinematics of rigid bodies and try to apply the equations that we have derived till now. Okay, if you have any questions, you can ask. Okay, that's all for today. We'll solve questions based on these problems hopefully tomorrow. Thank you.